And now we come to our last Spring REST lesson. And here we will review error handling, improving discoverability with an index endpoint, and testing our REST endpoint. So let's review error handling. It's crucial to provide meaningful error responses. The key aspects of error handling in RESTful services is ensuring that the correct HTTP status codes are returned. Here's an example of a response status of HTTP not found. And here is how you can code throwing the exception if you do not find the charity mapped to the charity ID. Then there's a review of how to declare exception handling. Spring provides the exception handler annotations where you can define custom exception handling methods within your controller. Here's a REST controller. Here is throwing a custom charity not found exception. Here is the exception handler defined where it returns the message and the HTTP status. Then Spring also provides the controller advice annotation. And what does this do? Provides global exception handling, provides global model attribute, and global data binding. So when you mark a class with the controller advice, you are essentially telling Spring to manage that class as a bean, making its methods available to provide advice to multiple controllers. This helps in keeping your code clean, modular, and reusable, as common concerns can be handled in a single place rather than duplicated cross-controller. Here is an explanation of using the base packages, annotation. Here is the benefits, code consistency, reliability. This is for self-study in our code. We have single annotation, and you can create this annotation in your controllers. And here is the steps that you can do to add error handlers and exception handlers. First, you create the custom REST stereotype annotation. Then you create the global error exception handler using controller advice with the example. And you use your custom annotation in your controller. Basically, the annotation bundles REST controller and request mapping, ensuring that all controllers using it follow a consistent API structure. And global exception handling restricts the scope of the advice to controllers that are annotated with API controller. This means any exceptions thrown by these controllers will be handled by the methods in the API exception handler. So now we go to Eclipse, and for self-study, let's look at what we have. We have our registration REST endpoint decorated with the REST endpoint, and we see all our mappings, and we see this is how we currently throw our exceptions on discover and read, as well as delete. And here is our REST endpoint defined. Working from the example, we will have to start with a REST endpoint advice, and then we will have to expand our controller with the API exception handler with the add controller advice. And in the API exception handler, we specify all the errors and what needs to be returned. So exception, specific exception. And now any controller that you decorate with the API controller will inherit those configurations and the error logic. So you have your custom annotation that bundles your REST controller, REST mapping, ensuring that all controllers using it follow a consistent API structure. And then you have your global exception handler. The controller advice combined with annotation restricts the scope of this advice to controllers that are annotated with API controller v2. This means any exceptions thrown by these controllers will be handled by the method in the API exception handler. There is your self-study exercise. And here is the branch that you can fork to play around with. Now we take a look at improving discoverability with an index endpoint, where we create a central endpoint that provides a list of available API endpoints and with brief descriptions what each endpoint does. We create a new method in the controller. We set up a mapping and we create a linked hash map, and in there we put the mapping and the description. So it returns a map of available endpoints and their description. You can also enhance the index with more information. You can do get, endpoint, description, parameters. Once you have implemented an index endpoint, you can test it. And you can also use index API versioning, where we start version 1. Every time we change it, we bump up our version. So we have improved discoverability, we have self-documentation, ease of use, and a centralized overview for the developers that use our API. Now let's look at testing our Spring REST endpoints. And in the previous two, we used SOAP UI, testing our REST endpoints. And we'll just quickly look at what other tools are available. Postman. Curl is a command line for Unix. And there is JUnit with Spring Boot Test. There is Rest Assured. And another popular one is Swagger/OpenAPI. Now once you've chosen your testing tool, you create your request, your REST endpoints, and you verify the responses. Here is an overview of how to use Postman. Curl, you can see, is a command line. And then JUnit with Spring Boot Test. You write your test class and you perform your test. And there's Rest Assured. This is another Java library with test even. And of course, these are pretty well used tools. There are probably a bunch of new ones that you can use as well. And it's important that you test all your REST endpoints. And that concludes this tutorial. I will see you in the next one.